Hi students, welcome to the physics class school foundation program. Today we are going to take the ninth class physics session. We would like to go for the discussion of conversion of units from one system of units to another one, and also we would like to go for the help of dimension analysis to convert one system of units into another one. Let's see. Yeah. Okay, we would like to go for that problems based on the conversion of physical quantities and the dimension analysis. Okay, we would like to go for this one. It's very clear. Yeah, if you are looking into the matter of the physical quantities, the quantities which are measurable are known as physical quantities, no doubt at all, right? While you are going to take that, in order to derive the one derived quantity, you need to raise the power, that is the base quantity's power has been raised to get the derived quantity. All right, it's very clear. That's what we would like to go for, that dimension analysis. Very simple. If you are going to look into the matter of joule, yeah, 1 joule is equal to 1 Newton meter. It's very clear. So you have taken that 1 Newton, it's going to be 1 kg meter per second square. It's very clear. Yeah, it has the displacement that is going to be 1 meter. All right. So we would like to go for this dimension analysis. Yeah, physical quantities, what we have discussed, that it's very clear. Yes, it's very clear. We would like to go for that measurable quantities are known as physical quantities. It's very clear. It's very easy for you to get that dimension analysis also. So dimensions, you have to take that, yeah, the powers base quantities. It's very clear. We would like to go for this one. Now we would like to go for the problems based on this one. Example, if you are going to get that force, yeah, you have to get that MLT minus 2. You have to get this one, dimensions are there. So if you are going to get that force per unit area, just if you have taken that force per unit area, that it represents the pressure. It's very clear. Suppose if you are going to get that force into displacement, it's very clear. It's going to be so it is equal to work done. All right. So work done is equal to that energy. Yeah, you would like to go for this one. This is going to be energy. So you can get that 1 joule is equal to 1 Newton meter. It's very clear. We would like to go for joule. It is going to be the SI unit for the representation of energy. It's very clear. So you can take that joule, and it has been expressed in terms of the units, that is going to be Newton meter. It's very clear. So if you are going to take that work done, it's going to be the internal energy of the system or potential energy of the system. All right, very clear. So if you are going to get that representation of the joule in SI system or CJ system, if you are going for that values, let's see. Sometimes you can take that power is equal to W by rate of doing work. It's going to be the power. It's very clear. We would like to discuss. So the associated problems are also going to be discussed with the help of the dimension analysis, and we can convert that one system of units into the another system. Let's see. Yes, we would like to go for this one, power into time. Suppose if you have taken that power into time, that is going to be work done. So that does it represent the energy? If you are going to get the problems, let's see. Yes, which of the following does not give the unit of energy, you have to take this one. Let us have that. If you are going to take the options, you have to see, right. So, we would like to discuss about this one, that is, yeah, as the condition we have to verify, right, which of the following does not represent the energy. Okay. We would like to go for this one. Let us go for that. Watt second, okay, you have to get that. Generally we are going to take what it is for the power, it is going to be for time. Yes, we have discussed about that, that is power is equal to rate of doing work, that is going to be W by T, all right. So, it is going to be getting that work by time, just you have to write, it is very clear. Yes, therefore, power into time, that is equal to work, all right. We would like to go for this one, this is very clear for you. Yeah, if you are going to get that power into time, it is going to be, yes, that is equal to energy. Yeah, we have to consider work done is also energy. So, first option, it represents the energy, it is very clear, that is going to give that, it gives the unit of energy, it is very clear. Okay, all right. Kilowatt hour. So, if you are going to get that kilowatt, now you have to get that power, it has been taken watt, yes, it is going to be second, it is going to be having that energy, yes, you have to take that energy. Up to this extent it is very clear. The first one, does it represents the unit of energy, it is very clear, it represents. Now, we would like to go for that another one, kilowatt hour. Yes, if you have taken that kilowatt hour, it is also going to represent that energy, it represents the energy. Sometimes you can take that joules and kilojoules, you have to take that now, you have to confirm this is going to be, okay, right. Now, we would like to go for this one, second one, Newton meter. So, we have to look into that matter, that is very clear. You would like to take for that Newton meter. Yes, from the basic definition, if you are going to get that Newton, does it represents the, Newton is the derived unit for the force, okay, it is very clear. Force and meter, we would like to go for that, yes. So, that is going to be force into displacement, just we have to take that, yes, all right. So, force into displacement, that is going to be work done, all right, that is going to be energy, all right. So, from the given options, it is very clear that Newton meter, it represents energy, that is going to be joule. So, if you have taken 1 Newton meter, it is going to be 1 joule, it is very clear. So, everyone has to identify this one, all of you would like to go for this one. We have started from the beginning, that is going to be watt second, that is very clear. Kilowatt hour, it is going to be power consumption and measurement. We would like to go for the first and second one, yeah, for the small duration of the time we would like to go for that power second. Yes, in the domestic purpose we would like to use that kilowatt hour, it is very clear. Newton meter, if you are going to displace the one, yeah, just you have to take that 1 kg mass, it is going to be displaced 1 meter by using the just external force, it is very clear. So, all of them they have represented the energy, it is very clear. Now, it is time to have the look, that is the fourth option, that is going to be Pascal meter. Yes, it is very clear. We would like to go for this one, all of you have to see that. Yes, yeah, this is going to be it does not represents the energy, it is going to be unit for the pressure, it is going to be meter. Yeah, this is the correct one. All right. Now, we would like to go for that confirmation, that is the fourth one does not give the unit of energy. All right, it is very clear, you would like to go for this one. Okay. Yeah, let us go for another one, is it better? Yes, Dyne-Second, just we have to discuss about this one. Yeah, let us have look. Yeah, Dyne-Second is the unit of force, momentum, power, energy. Let us have the look into that matter. Okay. Yeah, if you are going to get that Dyne-Second, yes, you have to get that. Dyne is the CGS unit to represent the force, it is very clear, it is for that force. Yeah, this is unit of force, it is very clear. Okay, it is going to be unit of time. Yes, okay. Just you have to take this one, you can easily find out this. Yeah, you have to take that. We are going to get this one very easily, we can solve this problem. If you know that basic relations regarding to that force, if you are getting that mechanics, yeah, you need to get that, you know, force is equal to mass into acceleration, it is very clear. All right. So, if you are going to look acceleration, you can represent in terms of that u and v and t, it is very clear. So, this is going to be m into v minus u by t, it is very clear. This is going to be the first one. Now, if you are going to substitute this one for force, you can have that, this is very clear, we would like to go for this one. Now, you can go for this one, that is, yeah, m into v minus u by t into t. If you are going to get this one, that is going to get that mv minus mu, it is very clear. Yes, it is going to be change in momentum. It is very clear. All right, you would like to go for this one, change in momentum, it is very clear. So, B option is going to be the correct one, it is very easy. So, sometimes you can take that, yes, yeah, it was conformed momentum. All right, you have to get that, whether the units of change in momentum, it is going to be clear. Okay, what is the additional information that you have been learned? Yeah, you can get that force into time, that gives the impulse. All right, that gives impulse, it is very clear, you would like to go for this one, or agree? Yes, this is going to be identified. Impulse, it is going to be a drastic change in the momentum within the short interval of the time. Just we have to confirm it is going to be the, it is equal to the phenomenon, right? Impulse, yeah, you can get that change in momentum. It is very clear, you would like to go for this one, right? This is the additional information what we have. So, the Dyne-Second, it is going to be having that unit of momentum, and also you have to take this one force into time, that is going to be the representation of that impulse, right? Have the look into that matter, we would like to go for this answer. Everyone has to identify this one, yeah, force into time is equal to impulse and change in time, that is the additional information, you would like to have it. So, okay, right, let us go for that another one. Yeah, Joule second, it's a unit of, you would like to go for this. Yes, okay. First of all, we would like to go for that. Joule second is the unit of the either energy, angular momentum and the power. We would like to discuss this one, it's very clear. So, you have to take that Joule. Yes, if you are going to get this one is equal to Newton meter, it's going to be mass into acceleration into, yeah, it's going to be displacement. Very clear, we would like to get that. That is, yeah, we would like to go for that acceleration. Easily we will identify this one. Okay, right. Yes, if you are going to get this one, that is you have to get this mass into acceleration is going to be, it's very clear, acceleration into displacement. Okay, it's very clear. Now, if you are going to get that, right, it is identified that Joule per second, it's going to be identified that mass, acceleration, and let us assume this is going to be the x, it's going to be, yeah, all right, it's very clear, we would like to get this one. So, you are going to substitute that mass, acceleration, and that this is going to be the displacement is going to be, or let us assume, yeah, it's very clear, and this is going to be the second. So, m, yes, if you are going to get that L by T square, you have to get this one, and this is going to be L, this is going to be T, just we have to get that mvr, right. So, this is the unit for angular momentum, just you have to take this one, all right. Now, you are going to identify this one, that is going to be m L by T into L. So, you will get that this is going to be, yeah, you have to take this one. This is very clear, this is going to be angular momentum. All right. Apart from that, you have to check, no, it's not at all going to be momentum, it's not at all going to be energy, all right. Now, let us have look into that matter. If we are going to get that power, it's going to be work done by time, yes. So, if you are going to get that Joule, you can take that time. So, yeah, you have to take this one. If you are going to get that work done, it is going to be Joule second, okay, all right, it's going to be Joule and second. So, power also it is going to be represent that power, it's very clear, okay. While you are going to check that m L t minus 2 into L by t. Just you have to ml square t minus 1. So, you have to get this one angular momentum also. If you are going to get that ml, yeah, if you are going to get this ml square t minus 1. Okay, it is very clear. You are going to have the look into the matter, that is joule per second, it is a unit of angular momentum as well as that power. You have to confirm this one, it is very clear. We would like to go for this one. Okay, it is easy for you to have the this unit. Okay, this is going to be getting this one. Yeah, this is going to be having the answer to represent the answer. Yes, let us have the look. Right. Okay. So, while you are going to solve these kind of the problems, just you have to take the help of the dimensional formula. It is better for you to get that relation. Yes, dimensionally they are going to check that it is going to give the answer. Okay. So, yes, let us go for this one. Yes, while you are going to get that current density, if you are talking about that current density, we have to represent, yeah, we would like to go for that in that area. So, the number of electrons which are going to be you can get that, you can get the area. They are crossing that area. If you are going to identify this one, yes, yes, you have to take that current density that is going to be J is equal to I by A. Yes, you have to confirm this one. If you have taken that current, yes, you have to take that I, and you have taken that area A, that gives the current density per unit area. Just you have to get current per unit area, that gives the current density. We have to take this one. This is very clear. The number of charges crossing per crossing the area, unit area. The number of charges that constitute that the displacement of the charges which constitute the current. It has been measured per unit area. It gives the current density. No doubt at all. It is very clear. Yes. Now we are going to have that dimensional formula for that one. So, very clear, we would like to go for this. Yes, if you are going to get that I is equal to current, it is the current, right. It is going to have the relation I is equal to Q by T, all right, it is very clear. Yes, we would like to go for this one, and A is the area. We would like to go for that L square. Yes, okay, you have to get that coulomb, we have to get the measurement for that current. If you are going to take that one charge as it crosses that unit area, you have to confirm that 1 coulomb per second. It is very clear, that is going to be the 1 ampere. We have to confirm that basic fundamentals, very clear. Now, therefore, I by A is equal to J is equal to I by A, that is you have to take this one, that is Q by T by L square. Just you have to see what we are having, that there is no M, yeah, you have to take this one, right, you can take that, yeah, the first one M power 0 and L power minus 2. This is going to be the correct one. Yes, we would like to go for this one, the dimension q. If q represents the charge, that is going to be getting that coulomb, unit for that coulomb. We would like to go for this one. Okay, right, let us go for that another one. So, this is a one important question to have that conversion from 1 joule into 1 erg. So, both are the derived units to represent the energy. If you are going to take that joule, that is the energy in SI system, we would like to go for that unit. While you are taking that erg, it is going to be CGS unit to represent the energy. It is very clear, we would like to go for that. So, with the help of the dimension analysis, yes, yeah, dimension analysis. Yeah, is to convert one system of units, to another. It is very clear, we would like to go for this conversion. Now, if you are looking that matter, the expression which is going to be involved in the process of conversion, just we have to take this one, that is N1 m power a m1 L1 T1 power b power c, that is going to be equal to N2 to m1 m2 power a L2 power b T2 power c. It is very clear. So, N1 and N2, they are going to represent the value. The base quantities power has been raised, that is going to be that mass, length, time in one system. It is very clear. So, generally if you are going to get that, yeah, you have to take that. Yes. So, 1 joule is equal to 1 Newton meter. It is very clear. You would like to go for this one. This is 1 Newton meter what we have taken, but you have to convert into x, that is very clear. Yeah, you will take that m, generally you are going to representation in terms of the base quantities, that is L T minus 2 and L. So, you will get that m L square T minus 2. So, you are getting that. So, m power 1, L power 2 and T power minus 2. It is very clear. So, you have to get this expression here. You can take that A is equal to 1, B is equal to 2 and C is equal to minus 2. It is very clear. You would like to represent that value. Yes, that powers are going to be defined by getting that relation. All right. So, you have taken A is equal to B, A is equal to 1, B is equal to 2 and C is equal to minus 2. It is very clear, we have all getting it. So, if you are going to take that, its representation in the different system of units, you have to take this 1 joule value, that is going to be you have to take that this is one system, this is another system. We are going to joule and erg, we would like to go for that relation. So, you have to convert joule into erg, it is very clear. now we would like to go for this conversion, right. You have to find out this N2 value, all right. Now you would like to, one N1, it is going to be, find out this one, this is going to be taken, right. We would like to go for this conversion, right. Okay, let us have the substitution, it is very clear. Yeah, we are going to take that, yes, 1 kg, yes, warm meter and 1 second. So, 1 gram, 1 centimeter, 1 second. We have to take this in the two system of units. We can represent the base quantities in terms of their units. It is very clear. All right, we would like to go for this one. Have you got this point? Now we would like to go for that calculation part. Yes. Okay, we would like to go for this one. This is going to be identified. You will get that N1 is equal to 1, N2 is equal to question mark. We would like to get this one. N2 is equal to, yeah, M1 by M2 power A. We would like to go for that L1 by L2 power B, T1 by T2 power my C. So, you are getting that M1 by M2, just you have to take the values, that is better for you. You are going to get that substitution and you will solve the problem, right. Yes, if you are going to take this 1 kg by 1 gram power 1, 1 meter by 1 centimeter, and you can take that 1 by 1, it is going to be minus 2, it is going to be 2. All right, it is very clear. You can take that 10 power 3 and you will take that 10 power 2 whole power 2 and 1 power minus 2, it is very clear. So, finally, you got the answer, that is going to be 10 to the power of 7 x. You have to get that. Yes, in this way you can solve the problem, just you have to take that, this is going to be the B. So, 1 joule is equal to 1 joule can be represented in terms of the x, that is going to be 10 to the power of 7. It is very clear, you would like to get this one. Now, if you are going to have the matter in the representation in actual practice, what we are going to get this, right. Do you know, while you are going to have that Planck's constant, if you are going to have that general use of that joule and x, the value of the Planck's constant is going to be expressed. You have taken that h is the Planck's constant, which represents the energy, it is very clear. Now, if you are going to get that Planck's constant value, that is 6.625 into 10 to the power of minus 34 joule second, it is very clear, all right. So, in terms of joules and in terms of x, you can write down. You will take that 6.625 into 10 to the power of minus 34 joule second. So, 6.625 into 10 to the power of minus 34 into 10 to the power of 7 a second. It is very clear. All right, you are getting that. So, very easy for you getting this one. Yes, we are going to get h value 6.625 into 10 to the power of minus 34 into 10 to the power of 7 egg second. It is very clear. So, if you are getting that value, yes, you will get that 6.625 into 10 to the power of minus 27 second. In general usage of this Joule and erg in the representation of Planck's constant, which is going to be having that quanta of energy, we would like to go for this one. So, this is useful for the higher classes to solve the problem, it is very clear. So, you need to know about that constant, Planck's constant, which is going to be represented in terms of joules and ergs. All right. So, we would like to go for that another topic, another, yes, right. Okay, it is very clear we would like to go for this base units, that is fundamental units. They have given that force, work and velocity taken as the fundamental quantities, all right. Then the dimensional formula of the time, while you are going to get that dimension analysis and principle of homogeneity, you can express that the base quantities are going to be represented as force, work, just what they have given you can write down. Yeah, you have to get that force, that is going to be work and velocity. They are going to be taken as the base quantity, it is very clear. In general, we are going to take that mass, length, time, they are all base quantities. But what they have given? They have given force and work and velocity, they are the base quantities. So, they are going to be having that relation with the time, just you have to take this one. Then the dimensional, if you have been considered that the base quantities are going to be force, work and velocity. What is the dimensional formula of this time? Generally, instead of these MLT, we have taken that force, work and velocity. It is very clear. You would like to know about this one, right. So, you need to express that time in terms of that force, work and velocity, very clear, we would like to know. In the beginning of this class, we have discussed about that work done, right, later we will see. Yes, you have to take this one, this is very clear, we would like to go for this one, right. We know that, please, we have to write down. Work done is equal to, we have to consider is equal to force into displacement very clear, we would like to go for this one. Yes, we would like to write down, therefore, work done, that is going to be W, that can be expressed as force, and displacement is going to be taken as L. Generally, we would like to take this one, all right. Okay, what we are having, this is very clear, we would like to go for this one. This is equation number 1, let us assume. So, rewrite, you have to express in terms of t, just you have to rewrite this equation by multiplying t, yeah, that is going to be rewrite equation 1 as W is equal to F into L into T by T. Yes, so if you want to replace this one, if you are going to T and T, just you have been multiplied and divide with the T, it does not affect the original meaning of that equation, all right. So, you have to take that, this is going to be F V T, what we are getting that W is equal to F V T. Just have the look into that matter, please all of you. What we have been considered, force, work, velocity, they are going to be the fundamental quantities. Okay, all right. Then the dimensional formula of time, if you have been considered in this system of the base quantities instead of MLT. Yes, we know that work done, that is going to be the force into displacement. It is very clear. We would like to write this one. It is very clear. Yes, we have to rewrite this one. Yeah, work done is equal to, that is going to be force into displacement. It is very clear. Therefore, W is equal to force into L, generally we have taken. So, that is going to be F L, just you have to multiply and divide with the T. That is going to be F L by T and T, that is equal to F V T, that is equal to F V T. All right, you know very well about that. Velocity is equal to displacement by time, just you have to write down, you have to take this one. All right. So, V that can be represented with that. We have been replaced this one, it is very clear. Yes, what we have considered, you have to see this one, we have to take this one. So, if you want to get that dimensional formula for the T, just you have to write down from this equation. Therefore, T is equal to, yes, you have to take this one, that is going to be W by F V, that is going to be F minus 1 W V minus 1. It's very clear. Just you have to see this, yeah, if you are going to take this one, right, F power minus 1, V power minus 1 and W power 1, that is the correct answer. Okay. If you have written, you are going to express this one, write down, you can take this. Yes, you have to write, that is going to be W power 1, F power minus 1, V power minus 1. Whatever that you have been written in terms of that W, F and T, it is very clear, you can easily find out this. All right, students, this is the answer. Okay. So, all of you, have you seen, this is going to be the method to solve any problem. Thank you very much. Have a nice day. We would like to discuss more number of problems.